Download this code from codegive.com, link in the description below. Locking fails with extra pip args, proxy, GitHub, and more. A comprehensive guide. This tutorial explores a common issue faced when using pip with extra arguments like proxies or when installing from private GitHub repositories, specifically focusing on situations where dependency locking fails. We'll delve into the underlying reasons, provide practical solutions, and offer best practices to prevent these problems. Understanding the problem, deterministic builds and hash verification. At the heart of the matter lies the concept of deterministic builds. Dependency locking, using tools like pip-freeze, pip-tools, poetry, or pipenv, aims to ensure that your application uses exactly the same versions of dependencies every time you build. This dramatically reduces the works on my machine syndrome and ensures consistent deployments. This is achieved by recording the hashes, cryptographic checksums, of the packages being installed. Pip verifies these hashes during subsequent installations to guarantee that the downloaded packages are identical to those previously locked. The crucial point is that pip and its related tools primarily use the package index, pipi, as the source of truth for hash verification. When you introduce extra arguments that alter the package resolution process, example using a proxy, installing from a private GitHub repository, or overriding index URLs, you can disrupt this hash verification process and trigger locking failures. Common scenarios leading to locking failures *. 1. Proxy issues *. Reason *. When using a proxy, pip might cache packages through the proxy. The cached versions might have subtle differences compared to the original packages on pipi, example stripped metadata, modified timestamps. When you try to install from the locked requirements, pip downloads from the proxy cache again, calculates the hash, and finds that it doesn't match the locked hash. Example requirements.txt, example. If the proxy modifies the request's package even slightly, the hash validation will fail. 2. Private GitHub repositories Reason when installing packages directly from GitHub, using git plus https://github.com/egg equals package_name, pip doesn't usually have a direct way to verify the hash against a central authority like pipi. The package source code from GitHub might have been updated, even subtly, since the original lock file was generated. Moreover, pip versions before 20.3 didn't handle hash verification well for VCS, version control system, dependencies. Example If the your_ package on the main branch has been updated since you generated the lock file, pip will likely fail with a hash mismatch or could not install packages due to an environment error because it doesn't have a hash to verify against in the first place. 3. Index URL overrides Reason using I or -index URL to specify a different package index, example a custom mirror, will inevitably lead to hash verification failures. Packages hosted on alternative indices often have different hashes compared to their pipi counterparts. Example If you later try to install from a lock file generated against pipi, the hashes will definitely not match. 4. Mixing installation methods Reason if you initially install some packages using extra arguments, like a proxy, and then try to install everything from a lock file generated without those arguments, you'll likely run into hash conflicts. The lock file reflects the clean pipi state, while your installation is influenced by the proxy, or other extra arguments. Solutions and best practices 1. Lock in the same environment you deploy to *. Principle *. The most important rule, generate your lock file in the exact same environment where you'll be deploying your application. This means using the same proxy settings, GitHub access tokens, and index URLs that you'll use in production. Practical implementation Docker/containers build your lock file inside the Docker container where the application will eventually run. This ensures that the environment is consistent. Virtual environments if not using containers, create a virtual environment and configure your proxy settings within that environment before generating the lock file. CI/CD pipelines in your CI/CD pipeline, make sure that the job responsible for generating or updating the lock file has the correct proxy and authentication settings configured. Example, Docker. To use -trusted host for pipenv files.pythonhosted.org with proxies reason this option tells pip to accept connections from these hosts even if they are behind a proxy without proper TLS verification. It is essential when using proxies with pip to avoid SSL certificate errors and to ensure pip can properly access PyPI and download packages. Files.pythonhosted.org is where the actual package files are hosted. Implementation Include -trusted host in all pip commands, especially during installation and lock file generation. 3. For GitHub dependencies, use pip-tools or similar tools with editable installs reason tools like pip-tools provide better control over dependency resolution and locking. Using editable installs, is often necessary when installing directly from VCS repositories to allow for updates to the source code without reinstalling. Implementation, using pip-tools. Pip-compile will analyze the GitHub dependency, fetch its dependencies, and create a requirements.txt file with properly pinned versions. Make sure your proxy is configured before running pip-compile. 4. Consider Poetry or pipenv reason these tools offer more sophisticated dependency management capabilities, including built-in support for virtual environments and locking. They often handle complex scenarios, like GitHub dependencies, more gracefully than pip-freeze. Example, Poetry. Poetry automatically manages the virtual environment and creates a poetry.lock file that tracks the exact versions and hashes of your dependencies. Configure your proxy settings before running Poetry install. 5. Avoid overriding index URLs unless absolutely necessary reason using I or -index URL makes dependency locking much more difficult. If possible, stick to the standard PyPI index. If you must use a custom index, example for internal packages, ensure that it contains all the dependencies required by your application and that you generate the lock file using the same index. Alternative if you need to supplement PyPI with additional repositories, use -extra index URL instead of I. This allows pip to search PyPI first and then look in the extra index if a package isn't found on PyPI. However, be aware that this can still introduce complexities with hash verification if packages with the same name exist in both repositories but with different hashes. 6. Use explicit version pins, even with lock files. Reason while lock files are great, adding explicit version pins in your requirements.in, for pip-tools, or pyproject.toml, for Poetry, adds another layer of security. It's a good way to explicitly define which version of a direct dependency is required. This can help identify inconsistencies earlier. Example, requirements.in. 7. Clear the pip cache regularly reason pip caches downloaded packages to speed up subsequent installations. However, if your proxy or environment changes, the cached packages might become outdated or corrupted, leading to hash mismatches. Implementation *. Run this command periodically, especially before generating or updating your lock file. Using -no cache dir during installation avoids caching altogether, but it slows down the installation process. 8. Consider vendoring dependencies, for extreme cases. Reason * in very sensitive environments where strict control over dependencies is critical, example security critical applications, you might consider vendoring. This involves copying all the required dependencies directly into your project's source code. This removes the reliance on external package indices and ensures maximum determinism, but it also significantly increases the maintenance burden. You are responsible for updating the vendor dependencies yourself. This is a last resort, however. 9. Be mindful of git tags versus branches *. Reason * when installing from GitHub, it's generally preferable to reference a specific git tag, a stable release, rather than a branch, like main or develop. Branches are subject to change, which can break your lock file when the branch is updated. Tags represent immutable points in the repository's history. Example *. Troubleshooting steps *. 1. Verbose output * use pip install vvv, to get very detailed output from pip. This can help pinpoint the exact package that's causing the hash mismatch and show you where pip is attempting to download the package from. 2. Check proxy configuration * double check that your http_proxy, https_proxy, and no_proxy environment variables are correctly set. Verify that your proxy server is running and accessible. 3. Inspect the cache * look at the pip cache directory, usually in your user's home directory, to see if the packages are being cached correctly and if they are being downloaded from the expected sources. 4. Regenerate the lock file * if all else fails, try regenerating the lock file in the correct environment. Make sure all the necessary proxy settings, authentication tokens, and index URLs are configured before running pip freeze, pip compile, or poetry lock. Start with a clean virtual environment if possible. Code example, illustrating the correct approach. Key takeaways *. Consistency is paramount * lock in the environment where you deploy. *trusted host is essential when using proxies with pip. Use pip-tools, poetry, or pipenv for more robust dependency management, especially with VCS dependencies. Explicit version pins add an extra layer of security. Clear the pip cache regularly to avoid stale packages. Understand the impact of index URL overrides. By following these guidelines, you can significantly reduce the risk of dependency locking failures and ensure more reliable and reproducible builds. Remember to adapt the examples to your specific environment and tooling.